Okay, so I'm going to work through some of these problems. I don't know if they're in the right order. I just copied them from the pictures. And if you have questions, you can let me know. Uh, so we start out with graphing and this function tangent. So you already got the period because the period normally for tangent is pi. And so you divided that by 2. And the other thing you can do when you go to graph, normally every pi, there's an asymptote. And if you were just graphing tangent of pi, that's what you'd make these asymptotes. But since the period is pi over 2, that means every pi over 2 there is an asymptote. So there's one, it shrinks it down. And then the goes right through the middle and goes up, makes these. And the reason is that tangent is sine over cosine. So everywhere the sine is 0, you have an x-intercept. Everywhere the cosine is 0, you have an asymptote. So there'd be asymptotes every pi over 2. The amplitude is just a number out in front, so the amplitude is 1. Doesn't really change anything. These are some oblique triangles. That means they're not right triangles, so you can't use SOHCAHTOA. So you have to use law of sines or law of cosines. And the way that you can tell is if you know an angle and the side across from it, you can use law of sines. So this one is a law of cosines question. And this one, since we know the angle and the side across from it, we can use law of sines. So I'm going to start with that one because it's easier. So the side over the angle across from it equals the side over the angle across from that. And I'll let you do that on your calculator, but you want your calculator in degrees for this one. So you would take 20 times the sine of 45 and then divide that by the sine of 120. Sorry for the sloppy writing, it's my pen. So just make sure you hit equal before you divide by sine of 120, and that will get you that number. For the law of cosines, I don't know which formulas you guys have. If you have it solved for cosine, but the cosine of your angle, so I think the law of cosine is a squared equals b squared plus c squared minus 2bc cosine a. And so we're trying to find a, whatever you're trying to find, that's what you want to call, you can call it a, and you can relabel if you want. So it's the two sides squared. And so you simplify that mess, you can put it all in your calculator and then take the square root of it, and that will get you the answer. So if there's not a right angle, you can't use SOHCAHTOA. Okay, so we need a picture here for this one. Fire tower A is 8 kilometers west of B. So if that's A, it's west, I think California, of B, and that is 8. And a fire is spotted tower A in the direction of 32 degrees northeast. So if you read that east of north instead of northeast, you know that east of north would be this direction up here. And that would be 32. From tower B, the fire is in the direction 63 degrees west of north. So again, there's your north. 63 degrees west of that. So you always reference the north. So you either go west of it or east of it. Find the distance from the fire to the nearer tower. Okay, so I would redraw this triangle. And you know that is 8. And these make a right angle. So if that's 32, this is 58. And if that's 63, this one's 27. And so 58 plus 27 is 85. 180 minus 85 is 95. So now you know all three. And so since it's not a right triangle, we can't use SOHCAHTOA, but we know the side across from the angle, which means we can use law of sines. So 8 over sine of 95 equals, call that x if you want, x over the sine of 58 and call that y equals y over the sine of 27. And so if you solve this one first, cross multiply like we did on the other one, so 8 times sine of 58 divided by sine 95, and then your second equation, 8 over sine of 95 equals y over sine of 27. So 8 times sine of 27 divided by sine 95. I'll let you solve those. Again, your calculator has got to be in degrees because these are in degrees, not radians. For rectangular coordinates and polar coordinates, I had to do a little review myself. I haven't done these for a while. So I looked up, there's a conversion. And so you convert using Pythagorean theorem, and then you find the angle. So polar coordinates are r, theta. And so to find r, it's just the hypotenuse. So square root of x squared plus y squared. And then to find theta, you take the inverse or the arctangent of your two coordinates. So for this first one, r would be the square root of negative 1 squared plus negative 1 squared. So 1 plus 1. So r is the square root of 2. And theta is the arctangent of negative 1, or 1 over negative 1, doesn't matter, negative 1. So where is the tangent equal to negative 1? Well, all of the tangents are equal to negative 1 at the 45s. They're either 1 or negative 1. So at 45 degrees, and since it's negative, it would be right here. So we have that angle is 3/4 pi, or 3 pi over 4, because all of these are fourths. So the tangent here would be 1, the tangent here would be 1, the tangent here is also negative 1, but we're just picking one of those values. And so it says find one set of polar coordinates for the point and plot the point. So you have a point right here. To plot it on this weird little thing. So it's going to be on on this axis, and square root of 2 is a little bigger than 1, a little less than 2. So each one of these rings is equal to 1. So that's 1, and then that's 2. So it's somewhere in between there. That would be your point. Sorry, that's kind of hard to read. So for the second one, to find the radius, square root of 3 squared plus negative 1 squared, which is the square root of 10. So that's your x, kind of like your x coordinate. That's your r coordinate. To find theta, we have to do the inverse tangent of negative 1/3. And so that is not on the unit circle. So you want to use your calculator to find it. It'll be a decimal value, and we're getting approximate. So this time you want your calculator to be in radians. And I'm just going to stop and do it in my calculator real quick. So second tan of negative 1/3 is negative 0.3127, which would be somewhere down in here. So if you take that away from 2 pi, that would give you your value, because we want to go the other direction. So 5.97, so almost 6. You could find the exact values here. Just double check and make sure I put that in right. But you're approximating it. So the radius is a little bit bigger than 3. So this is your 3 circle. And then your value, negative 0.312 is close to 0.3. 0.33 would be pi over 6. So it's in here somewhere if you're plotting a point. But I don't know how detailed that has to be, but you're following that same process. Do the same one here. The radius is the square root of 5 squared plus 12 squared, which is 13. I don't know how you're going to plot that, but somewhere way outside. And then inverse tangent of 12 over 5. You got to put in your calculator. And you get 1.176. So again, remember this is pi, so this is 3.14. This is half of pi, so it's 1.57. So 1.1 is, somewhere in between here is like 0.8. So 1.1 is somewhere in this area, and then you'd have to plot it all the way out here at 13, because that is the radius. I haven't plotted those coordinates for a while. You might double check on the plotting, but that's how you find the point. Solving trig equations. So you just want to do uh, algebra kind of things on them, but you always can change everything to sine and cosine uh, and solve. But if we're solving, we want to simplify it down to where we can use our calculator or use the unit circle. So I would get everything equal to 0. So bring this over. So cotangent x cosine squared x minus 2 cotangent x equals 0. Really sloppy. So if you take out the cotangent, you're left with cosine squared x minus 2 equals 0. So it's just like when you factor and you have x and y minus 2 equals 0. You set each of these equal to 0 to see what the solution is. So where is the cotangent 0? And where is cosine squared x minus 2 equal to 0? So I'm going to start with the cosine squared one. So I'm going to get this by itself. Take the square root. And it'd be plus or minus square root of 2. Well, you can check that on your calculator. Use inverse cosine, but cosine is never bigger than 1 or smaller than -1. So there's no solution with that one. So we want to find where is the cotangent equal to 0. So on your unit circle, the zeros are at the different coordinates here. And the tangent is y over x. So cotangent is x over y. So I want to see where is x divided by y equal to 0. So that would be at pi over 2, because 0 over 1, and 3 halves pi. So it's where that's equal. The tangent's 0 at the other two. So there would be two solutions. There would be pi over 2 and 3 halves pi. And then it would keep repeating. So you could do pi over 2 plus basically every pi. It repeats. So sometimes, I don't know if she has you write like this, plus n pi. Because you keep adding pi's. You start here, add pi, add pi, add pi. It keeps going on forever. Again, I want to set everything equal to 0 so I can solve it. So I have 2 sine x plus radical 2 equals 0. Take the radical 2 over to the other side because I can isolate the sine. Now I divide by 2. So I want to know where is the sine equal to negative radical 2 over 2. So on my unit circle, the radical 2's over 2's happen at the 45's. So I want to know where it's negative. So it's going to be negative up here, or sorry, down here, because the y value is negative down here. So this is negative radical 2 over 2, negative radical 2 over 2. So one of them would be here, and one of them would be here. And then it would repeat. Again, I don't know if she has you repeat or just find one solution. You have to check on that. So this is pi. This is 1 1/4 pi. So also known as 5/4. That's 1 1/4. And this is right here is 1/4 pi, and it's 1/4 away from 2 pi, which would be 1 3/4 pi or 7/4 pi. And then these solutions both repeat every 2 pi. So if you're writing it as multiple solutions, then you'd say 5/4 pi plus 2n pi, or every 2 pi it repeats. And then also 7/4 pi 2n pi. So that just tells you that I have a solution, and I spin all the way around, I have a solution. And it just keeps going. I have a solution, it spins all the way around, I have a solution. All right. Okay, let me get some of this cleared off here. So solve this just like you would 2x squared plus x equals 0. You would factor out the x, and that would leave you with 2x plus 1. And so you'd set each of those equal to 0. So in this case, though, we're going to factor out cosine. And it leaves you with 2 cosine x plus 1. So I set that equal to 0. And I set this equal to 0. And I find the solutions on my unit circle. So where is the cosine equal to 0? Cosine is the x-coordinate. So pi over 2 and 3/2 pi down here as well. And then I solve this one for cosine. I take the 1 over and divide by 2. Where is the cosine? Negative 1/2. Again, cosine is the x-coordinate. So it's either at the pi over 6 or the pi over 3. And so you just have to know which one the x-coordinate is 1/2. And you can make a chart. I'm guessing you guys have memorized that. So I'll show you on the unit circle. So on the unit circle, the x-coordinate is negative 1/2 at 2/3 pi, and the x-coordinate is negative 1/2 at 4/3 pi. So and then those would repeat again. They repeat every 2 pi. So that goes every 2 pi, repeats, that goes. So sometimes you write it plus 2n pi. Okay, so this one, you see all these signs, just factor it like you would a quadratic. So 2x squared plus 3x plus 1 factors into 2x plus 1, x plus 1, which is 2 sine x plus 1 and sine x plus 1. So I set each of those equal to 0. Getting really sloppy. So this is where is the sine equal to negative 1/2. And then this one is where is the sine equal to negative 1. So if you just look at the unit circle again. So where is the sine? Sine is the y-coordinate. The sine is negative 1/2 at 7/6 pi and 11/6 pi. So those are two of the answers. And then the sine is negative 1. The sine is the y-coordinate. Can't see it on here, but the sine is negative 1 at 3/2 pi. So you have 3 solutions for that one. Graphing trig functions, you kind of go through it. The amplitude is the number in front, so the amplitude is 3. The period for sine is normally 2 pi, so we take 2 pi divided by the number in front. So the period is pi. That means every pi, the cycle repeats. So I'm going to make a little point just so I know that every pi, my cycle repeats. And the amplitude means it's going up and down from 3. So the basic graph of a cosine looks like that. So I'm starting at 3 and I'm ending at 3. So I know that's just going to keep repeating. And then I'm going, in the very middle, I'm going down to -3. And then what I always do is just make 5 points. So you have your starting point, your ending point, you have a point in the middle, and you have a point in the middle of each of those. And one period does that. It's crooked, but so I have 5 points. 1, 2, 3, and I make middle. It goes down to the first, turns around. So it just keeps repeating itself. Usually you have to graph 2 periods of it. So cosine basic graph starts and ends at the amplitude. If that's negative, it would have just been flipped. But that you need to know that basic. Whoops. I just graphed the cosine. I just graphed 3 cosine 2x. So let's make it sine. Graph of the sine with the period of pi. Basic graph of sine is that. And your 5 points would be 1, 2, 3, 4, 5. So it starts at, I'll make my 5 points. It starts at 0. It's going to go up to 3 at the second point and down to -3 at this fourth point. You just kind of sketch it in. And then you just repeat that cycle. So first point, last point, points in the middle. It just keeps repeating. Sorry about that. Okay, this one is cosine. So the amplitude is 4. It means we're going to stretch up and down to 4. The period is 2 pi over b. B is the number in front. So 2 pi over 1/2, which is 4 pi. So it's stretched out. So one period is going to happen all the way here. So if I make my 5 points, I have the starting, ending, I have the middle, and I have the middle of each of those. So all of my graph is going to repeat in that section. So since the amplitude is 4 and the graph of the cosine looks like that, I start at 4 and I end at 4. I'm going to get all the way down to 4 in the middle. That's where it turns around. So, and then you could do the same thing over here. So it goes to -4, halfway, halfway, halfway. The key is those five points. And so anything, the only thing that changes is where you start and end your points, and that is based on the period. Verifying identities, I would change stuff to sine and cosine whenever you can, or factor. So we want to get the left side to look like the right side. So if I change cosecant to 1 over sine squared minus 1 over 1 over sine squared, if dividing by a fraction is the same, multiply by the reciprocal. So I have 1 over sine squared minus 1 times sine squared. So when I multiply this times both of these, I get 1 minus sine squared. Well, 1 minus sine squared is equal to cosine squared, because sine squared plus cosine squared equals 1. So change everything to sine and cosine when in doubt. The other thing that you do is if there are fractions, anything like that, you want to add them together. So on this one, I think I'm going to change the right side instead of the left side. So I'm going to add those fractions. So I need a 1 minus cosine theta and a 1 plus cosine theta. So when I convert this fraction, I'm taking 1 plus cosine theta times 1, which is just 1 plus cosine theta, plus this one, I'm taking 1 minus cosine theta. So the cosines cancel out, and you're left with 2 over, and when you multiply this out, the outside and inside go away. So 2 over 1 minus cosine squared theta. If you distribute that out. Well, again, if you use your trig identity, 1 minus cosine squared is sine squared. And we know we got to get it to cosecant. Oh yeah, 1 over sine squared, that's equal to cosecant squared. So 2 cosecant squared theta. This thing is nasty. I would change this to sine and cosine. So tangent is sine squared over cosine squared. So this is cosine squared over sine squared. Because this one is smaller, I usually want to work with the bigger. Now we got to distribute. So I'm going to distribute this. So the sine squareds cancel out. You get cosine squared minus cosine squared over sine squared. And then I distribute here, that's plus sine squared minus 1. And that's still equal to this. So what can you simplify? Well, cosine squared plus sine squared is equal to 1. That's the most important one to know. So this is 1 and this is negative 1, so that's 0. So all you have left is negative cosine squared theta over sine squared theta, which is negative cotangent, because cosine squared over sine squared is cotangent. All right, that's pretty long. Let me know if you have questions and you need more help.